Hi and have a good day everyone. Okay, so today we are going to look at a random variables, probability distribution and the mathematical expectation. Okay, first we look at the definition of random variable. Okay, random variable is referring to a value capital X that representing a numerical value associated with each of the outcome of a probability experiment. So we have two types of random variable. The first one is a discrete random variable, which is takes on a finite or countable infinite numbers of value. For example, is the number of children. And then we have a continuous random variable that can take an on entire interval on a number line. Okay, for example, the weight of student, the height of student. Okay, and then next we are going to look at the probability distribution of a discrete random variable. This is a probability distribution for a discrete random variable that we define fx is equal to probability of capital X is equal to small x. So for the probability distribution to be valid, two rules must be satisfied. The first one, all the probability value must be greater than or equal to 0, and then the summation of all the probability value must be 1. For the distribution function, or we call as the cumulative distribution function, it gives the probability value less than or equal to the possible value. So it is useful when we want to summarize the probability up to a certain point. For the expected value or we call as a mean or average, it tells us what value we can expect on average if we repeat the experiment many times. So this is the formula for we to calculate the expected value for the discrete random variable. And then variance, okay, variance is referring to we are measuring how spread the value of a random variable from the mean. And then this is the formula for we to calculate the variance for the discrete random variable. And then for the rules of mathematical expectation, there are several useful rules. Okay, for example, the expectation of a constant, okay, the expectation of a constant is equal to the constant itself. And then if you multiply the random variable by a constant, the expectation scales by that constant. For example, for this one, alright. And then this rule actually allow us to simplify the complex problem and make the calculation more easier. Okay, so today we have learned about random variables, their probability distribution, the expectation, and then the variance. So in our next lesson, we are going to see how these concepts are applied in practice. So thank you for your attention.